today we'll be doing system design. So I have seen that many people struggle in designing the system. As an architect, we need to do the system design. So this is for those individuals who have experience, and for those individuals who is designing the system, who is responsible for designing the system, or the associate architect, or the principal engineer, or the senior architect, or for the enterprise architect. If you are any of them, uh, this video is useful for you. So let's begin. So in the system design, we'll be designing today messaging system. Now messaging system can be like WhatsApp, which many of us use, Facebook Messenger, etc. So a typical messaging system consists of like one user sends message to another, or one user can send message to a group of user. And in it, and if you have used Slack, for example, or if you have used WhatsApp, then you can create groups, and within groups multiple users can be added, and those users can collaborate in either in Slack channel or in WhatsApp group. So these are the different features which is needed in a messaging system. User can exchange text message, audio message, or video message. User can see the online status of another user. Group messaging is possible. Messaging between single and multiple user is possible. Then we also see the status for the missed message or the push notification that we get on Android and iOS device, like this is the message that is sent for you, since you were offline it was not delivered. Then user gets the read receipt and the group message. Group message is repetitive, let me remove this. And so this is the requirement, and suppose you are an architect and you have to design the system. Let's design the system, and before doing that, as an architect we know that NFR stands for non-functional requirement, so we need to take care of non-functional requirement as well. So whatever we will design, it should be secure, it should be reliable, it should have a low latency, and it should be highly scalable. Okay, so let's begin the design part. So to do that, I will be using draw.io. This is one of the online free tool which I use most of the time to design the application. You can use Lucid Chart as well, but today we'll be using draw.io to design the system. So I'll start the system in 2-3 ways, and I'll show you 2-3 different approach using which you can draw the messaging system. It just depends on how much load you have, what is the application need. Okay, so a simple application can be, suppose you are developing application which is not going to be used by suppose millions of users like Facebook or WhatsApp. If it is going to use by suppose hundreds of users or thousands of users within the organization, in that case one of the simple thing that we can do is, so suppose this is user 1, and this I will use user 2. So one user can send message to another user, and here I'm assuming you are using either web or Android and iOS. So to do that, let me check what are the different options that we have in draw.io. So user can send and receive the message either from Chrome or Android device, or an iOS device. Let me select it. Now this will be user can send message through browser or through some Android and iOS device. this can be iOS, this can be Android. Okay, and let me put it behind a container. Okay, so let me send to back. So user can be of Android, user can be of iOS. Let me sort it. Okay, now if user can send message through these things, user can receive as well, yeah, in Android, iOS. Okay, so here I'll give a pointer. So API, the backend API we can write that will send and receive, and to persist the message I'll be using some database. So this data will be read and written by API. So in this example we can see that user 1 can send message either from Android, iOS, or through web browser to user 2, and the message will be sent and received with the help of API, server API. Okay, now what is the problem in this? So if we have few hundreds user, for example 100 or few hundred, then the system may work. But if you have lakhs of user or millions of user, this system is not scalable. This is reliable in the sense that data, we are persisting the message in database, and that message will never get lost, and we can have some tables around it, like we can have some user, and we can have some another table which will be we can have user table, we can have a message table. Okay, user table can consist of like username, and this will be the unique ID, and message system can be of message type and actual message, like that. Okay, so this database, so this system can work but cannot be cannot scale well. So how can we make and one of the product requirement that we have is, along with that, scalability, highly scalable and low latency. In this diagram it is not it will not be having low latency as well. Okay, so this will not work. So let's design system which will be more secure, more scalable, and should be of low latency. Okay, to do that, let me delete these things. Okay, let me delete this as well. Now to make sure that every data that we sent will be secure, we'll be using HTTPS, which will have SSL certificate installed in it. Okay, now to make things more scalable, I'll be using load balancer. So instead of I will be using load balancer and a cluster of servers. So instead of having one API server, now I will have API server 1 and similarly API server 2, and let me draw another API server 3, and like that. Okay, we can have API server 4, and these all will be connected through load balancer. So load balancer will route the data, route the request to different API servers. Now to do that, load balancer can use first come first serve or any other strategy. Okay, now so the scalability problem is solved. For reliability purpose, we will again use database here. Okay, that will store user and message information. Okay, now since there will be millions of users who will be sending, so it is not so this database, the concurrent write request on this database will be huge. To solve that problem, we'll use some messaging service such as Kafka. Messaging service such as Kafka, which has very high throughput read and write. So every API server will write to messaging system, and there can be listeners which can listen to these systems. So API server will write and there will so it will be produced, and the same can be consumed by the consumer. Let me draw this. Okay, so we'll solve the reliability purpose by introducing a messaging service such as Kafka, and we'll again persist it in database. Now to make sure there is no database backend failure, we will have a cluster of database 2, so that master slave concept can also be there. So if master fails, slave will work, and if one database fails, we can others will be available. And if you're using cloud, in the cloud we AWS for example will use Azure instance. Okay, so that's there. Now to make so that solves the reliability problem, but how to solve the low latency problem? To do that, we'll be using some cache. Okay, so we'll use some sort of cache here. So messaging system will read from the cache. So as we know, cache we use for low latency, so that because database read and write will always be time consuming and costly, so that's why we'll use cache. So low latency problem can be solved here. Now if we need to store audio, video, image messages, send and receive, so in that case database will not be enough, so we'll use some sort of object storage. And in case if you're using AWS, then we'll use Amazon S3 bucket. Okay, so AWS provides storage service, object storage service, Amazon S3 bucket, where we can store all the image, text, image, uh, videos and audio files. So API server will write to these object storage, okay, and their path or the location will be stored in the database. Okay, let me do it a bit nicely. Let me send it back. Okay, and for database let's use this. To back. Okay, so we have database, we have the object storage. For now, let's see what is missing. So if can we reduce the latency more apart from cache? Yes, we can do that. That can be done using CDN. Let me see if I can get something for CDN. Yep, I have something for CDN object as well. So objects can be cached in CDN. So we use CDN. If if you guys have experience with web development, we know what is CDN. And CDN will cache the heavy media files, you can say, from this. So through the use of CDN and through the use of cache, we will reduce the latency. And so let's see what is left. Okay, now for status of missed message and read receipt, we will use something such as do we have anything of in terms of notification? Yeah, so we will use some sort of notification service. Okay, so we'll use some notification service. This will be written and read by messaging service, and that will also, this notification service will send the notification to this end user. Okay, let me duplicate this so that okay, so this notification service will send push notifications or read receipt. If you have missed the notification, everything will be carried by the notification service. So we solve this problem as well. Okay, security, as we are using HTTPS SSL, so everything will be encrypted. Amazon S3 will use IAM role so that it will be not accessed by anyone. So we'll use security group IAM as well. Okay, so we'll use security group and IAM to make sure in AWS these S3 is secure. Okay, and data cannot be accessed by any anonymous user. So here users, if you are anonymous user or kind of hacker, you will not be able, you should not be able to access any of the service that we have. This or this or this. Let me not draw this, it is too complicated it looks now. So anonymous user is not allowed. Okay, similarly for database also, and any anonymous user should not be able to access these things. Okay, so things are secure, things are scalable, things are reliable as well. Okay, so we have seen how we can build a system that is secure, reliable. Okay, this system is secure, reliable, as well as have low latency, and you can send messages, these all messages in this system. Okay, and what are the different tables that you need? So table 1 can be user table, table 2 can be message, table 3 can be group message, table 4 can be some sort of master table, message type master table. Okay, and along with that, if you want a regular backup of database is needed. Okay, so today we learned how to draw the system design, how to draw the system architecture diagram for a messaging system. Okay, so thank you viewers for watching. Do like and subscribe the videos, and if you have any question, please post in the comment section. Thank you so much for watching.